Okay, so before I talk about the code for the experiment, I kind of want to talk about the setup PWM before. So essentially, with this setup PWM, right? First thing that we have to do, which is in these two lines here, is essentially enable the clock for the PWM module, right? So once I do that, I then have to enable and set up the clock divider for the PWM timer, right? So that's pretty much what I do here. And then for this second, for this line on 116, essentially I have a divisor of 4. So the reason why I have a divisor of 4 will be explained once I talk about part 4 when I have to configure the load and the CMPA value. So hold hold that thought for just a quick second, or hold the reasoning why. I will explain it once I get to the load and CMPA values. So, um, right, so then next, pretty much what we have to do is we have to disable the PWM generator and set up the timer counting mode, right? So essentially, we want to disable the PWM generator and set to countdown mode, right? So now you might be wondering why there's two, right? Because one of them is for the LED and the other one is for the motor. So the one with the 0 is for the LED, and then the one with the 3 is for the motor. So these numbers, right, the 0 and the 3, are basically from the table that I will show now, and I will explain why we use it, or how we use it in this case. Okay, so real quick, right? So I want to show where I got those numbers from. Again, so if we look at our schematic diagram, right, we're going to use PF0, right, for our LED. And the PF0, right, if we look here, the generator is 0. So henceforth, that's why we have the 0 for the ones with the LED. And then we're also going to be using PK4, right, for the motor, right, to send out the signal to the motor. So that's sorry, that's down here, right? That's right here. Oops, that's this part, right? So if we go across, right, we see that this is generator 3. So therefore, it's generator 3. And also, we will see that in part 6, right? Um, in part 6, we're going to see this PWM0 output, right? Because again, we're using PF0 for the LED, and then for PK4, we're going to output PWM6. So yeah, so there's just two things to keep in mind. So again, this is the number, right? The number that we have, and then so this is the number, right? The number, and then for the outputs for part 6, it's just going to be these two. Okay, so let's get to that. Let's get back to our code. Okay, so again, just to kind of recap from what I explained in when we were looking at the chart, pretty much all this numbers is just the generator, right? That's that's all that number is. Okay, cool. So now to configure the load and the CMP, right, and the gen values. So first let's configure the load and the CMP, right? So um, let's get to that. Okay, so now let's calculate how we find the load, right? How we find the load for um, how we find the load, right, and the CMP value. Okay, so in order for us to calculate the load, right, essentially what I did was I used my divisor to be 4, right? So we know that our system clock, right? So the system clock is 16 megahertz, right? And I used the divisor of 4, the PWM divisor of 4, and we end up getting 4 megahertz, right? Okay. Now we know that the load, right, is equal to the FPWM timer, which is this. This is our FPWM timer. Oops, our PFWM timer. So we know that the load is equal to our FPWM timer over our FPWM, right? So in this experiment, our FPWM, or in both these experiments, right, the FPWM is 100 hertz, right? So if we divide 4 megahertz by 100 hertz, we get 40,000 hertz, and this this results with this being true, right? So essentially, because that's true, then it works. Okay, so now the reason why I chose 4 as the divisor is primarily because if I were to change this divisor to something lower, then essentially this value here would increase, and it would make this I'm gonna circle it in orange. It would make this thing not true. Okay, so yeah, pretty much that's the reason why I use the divisor for. Okay, so now let's get back to our code. Okay, so now that we have our 400 or our 40,000, right, which is obviously less than the 535, right? So that's fine. And then again, our load, our initial CMPA has to be less than the value, less than the value of the load. It can't be the same. So therefore, in order for it to be less, we just subtract 1. So yeah, and then we also know that from this system, it's basically a left aligned PWM, right? So that means it's going to go from a high, right, from a high to a low. And then another thing to keep in mind also is that again, since these have zeros, right, these are for the LED here. So pretty much we just repeat the same process for the motor, right? So as you can tell here, as you can tell from here, right, it's a 3, so therefore this is for the DC motor, right? So we just basically do the same thing, and also the it's also a left aligned PWM for the DC motor. So yeah, and again, we know that it's left aligned because it goes from high, right? It goes from sorry about that. It goes from high, right, to low. So yeah, and then pretty much then after we have to enable the PWM generator, and then we have to enable the PWM output. And yeah. Okay, so now let's talk about the setup GPIO, right? So essentially, for the setup GPIO, we have to enable the clock for the GPIO modules, right? So essentially, for this lab, or yeah, for this experiment, for this part of the lab, essentially you're going to use port F and port K, right? So we also have to allow time for clock to stabilize, right? For port F and port K, from port F and port K. Cool. So then now we set the port control register for each port, right? And because essentially we are using the port F pin 0 as a way to control the LED through signals, right? And we're doing port K pin 4 as a way to control the motor, so therefore that's why we have to do this. And then for this part here, we have to set an alternative function, right, to select set an alternative function select bits for the port. So that's essentially what we're doing here, right? We're just setting the alternative functions select bits for each port, and then pretty much at the end here, because we're not going to have we basically, since these are all GPIO pins, right, they have to all be enabled. So because they're essentially the same GPIO, that's why they all have to be enabled. So yeah, that's pretty much it though. So now that we have all this stuff, we can go on and talk about the code for the experiment. Okay, so now let's talk about the main code for the experiment. So pretty much, right, we have our, as we can see here, in our int main function, we have our array, right? So pretty much these values of the array are the duty cycle, right? The values at the CMP duty. So essentially, this number here is at 0%. This number here is at 30%, 60%, and 100%, right? Okay, so you might be wondering, how do we find those numbers, right? Well, I'm about to show you, so let's get to that. So, yeah, okay, so now let's go over how to find our values for our CMP duty array, right? So remember, from previously mentioned in the video, we found that our load is 40,000, right? And we want the CMP duty, right, cycle to go from 0 to 100%, right? Cool. So now in order for us to find those values in our array, pretty much what we do is we do the load, right? So it'd be the load minus the load times our duty cycle, right? Which is 0%, which in turn would give us 40,000, right? But because our initial value of our array cannot be equal to our load, it has to be less, we just subtract by 1. And that's how we get 39,990. Okay, cool. Now for the next value, right? So real quick, is it 0%? Okay, so alright, for our next value, we pretty much just do the same thing. It would be 40,000 minus 40,000 times 30%, right? And that gives us, let me plug that into our calculator. So we get 40,000 minus, so that gives us 28,000, right? And in this one, we do not subtract by 1 because we only want to subtract by 1 for the 0%. Yeah. Okay, so this is going to be for 30%, right? So these are equal. And yeah, pretty much what we're doing is we're just repeat the same process for all the percentages. So for the next one, which is 60%, right? Times 60%, we get 16,000. This is at 60%. And then at the full 100%, right? Minus times 100%. That would just be 0. Oops, it would just get 0. That's be 100%. Okay. Well, yeah, that's pretty much all the values that we're going to find in our array. Those values are this one, this one, this one, and this one. So yeah, now let's get back to our code. Oh, we're back, right? Okay, so now pretty much all we do is we initialize our I to be equal to 0. Then we create our array, right? Or we find our array size, right? The CMP duty array, this right here. We're going to find the size of that, right? And we'll, a little bit further on in the code, we'll see why we did that. And then we pretty much want to call back to our functions, right? To our setup PWM, which I had mentioned previously in the video, and our setup GPIO, right? Okay, cool. So now if we get into our while loop, right? Pretty much here, what we're trying to do is we're just trying to essentially find the CMP, right, for at each different duty cycle, right? Or at each different cycle. So pretty much I is going to increase, right? So we had set I to be 0. So the first is going to be 0, and then as I increases, this will essentially change. So essentially what's going to happen, right, is for each duty cycle there's going to be something's going to happen to the LED and to the motor, right? And this all depends on our schematic. So in experiment 1, the schematic is going to be essentially the schematic is going to allow the motor to run in a positive in a clockwise direction. As the light increases, it's going to get brighter, right? And the motor is going to spin faster. So now pretty much, right? So again, as I said, that was the that's essentially what we're trying to do here. And then pretty much this is where the array size, the function of the array size comes in, and where we have to check if the I is in the range of the array size. And then as this happens, each time we want, each time it starts over, right, we want it to have a weight 2 second delay, right? Because we want the motor to slow down completely and then start up again. So that's why we have that. So yeah, that's pretty much it. So now let's get to the results. Okay, so now let's see the results for, let's look at the results for experiment 1, right? So before I get into the actual results, here, as you can see, I have my Tiva board, I have my breadboard, I have my motor driver in the middle, I have my DC motor here with the fan that I connected to the top of it, and I drew arrows to signify when it was going clockwise and counterclockwise. Then I have here, I have my my power supply module, and then that's connected to an outlet that's just off camera. But yeah, so, and then the Tiva board is connected to my laptop, which is just right here. Okay, so yeah, so now that I pretty much have everything, now let's see how the code works, right? So I already have the code loaded onto the board here. So let me just click the reset button. Let me turn on this, right? Okay. Now when I release the reset, see, it's gonna turn on. This light is gonna get brighter, and then this here is gonna turn, the motor starts rotating in a clockwise motion, right? So, and okay, so there's two things to obviously notice. One, this light gets brighter here on the Tiva board. This LED right here, see, it's getting lighter as each as it goes from 0% to 30% to 60% to 100%. See? Yeah. See? 100. Yeah. See? And then if we look at the motor here now, we're gonna see as soon as it starts up again. Watch, we'll see right now. It's gonna go in a clockwise motion. See? It's going like this, starting off that way, clockwise. It's a clockwise motion, right? And as we can see here, this LED is in sync up with the fan, right? So as the LED gets brighter, this thing starts spinning faster, right? The fan starts spinning faster. So let's take a closer look at them together so we could actually see. See? And again, as we can see here, it's gonna go 0, 30%, 60%, 100%. See? And then now, yeah, so that's pretty much it. So essentially, it's just the motor that is rotating at different speeds, and the LED is also getting brighter as the motor spins faster. See, and yeah, that's pretty much the results for this one. So yeah.